Welcome back to You Revise, where we talk about everything exams. Okay, let's take a look at question 2 from the 2016 exam. It says sulfur can be obtained from hydrogen sulfide found in natural gas according to the equation below. This is the equation where we've got hydrogen sulfide reacting with sulfur dioxide, forming water and sulfur. And the reaction is endothermic according to this here, because delta H is greater than 0, and which means energy is a reactant. I always advise you to do this so that, if you've got anything related to energy change in temperature, you know how to handle that. Now, which one of the following changes will initially decrease the rate at which sulfur is produced? So let's read answer by answer here. Before we go on to that, actually, let's take a look at this one here. According to the examiner, 79% of candidates got this question right, which was really good. Now, let's get back to the question. It says, reduce the partial pressure of hydrogen sulfide. So if I decrease the partial pressure here, lower the partial pressure of hydrogen sulfide, what will happen? The system will try to oppose the imposed change by favoring the reverse reaction. I don't know why they didn't put this as a reversible reaction for that matter. I don't know. Look, it's CASA. They know better than I do. Probably there's something I'm missing there that should be looked into, but we are treating this as a reversible reaction, by the way. So we decrease this one here, the reverse reaction is favored, which means it's going to decrease the rate at which sulfur is being produced at that point. So if we look at a rate time graph, this will look something like this. I find this system at equilibrium, right? And both the forward and reverse reaction are occurring at the same rate. And on this side, by the way, I've got rate, and on this side, I've got time. They are occurring at the same rate. So when I decrease the partial pressure of hydrogen sulfide gas, the forward reaction, the collisions on this side will decrease. The frequency of collisions will decrease compared to the frequency of collisions on that side, which means this side is seeing a lot more collision, a greater frequency of collision than that side, which means equilibrium will shift back that way. So what I'm going to see is this. The forward reaction rate is going to drop. But then as this here builds up, again, try to build the hydrogen sulfide back up, it's going to increase that rate while the rate of the reverse reaction decreases. Okay, should have started by drawing that one all the time. I make this mistake. I can't draw. Anyway, that should be better now. It looks better. So this is the reverse reaction decreasing, which means this is actually resulting in a decrease in the rate of production of sulfur, which makes answer A correct. But we're not going to straight away jump and write that answer down, because in multi-choice questions, you have to think about it this way. Is the best answer. There are times when you've got two answers that are close to each other, but you must choose the most correct answer out of those two answers that look like they're close to each other. Now, B, increase the partial pressure of sulfur dioxide. If I increase the partial pressure of sulfur dioxide, the reactants will see a lot more collisions, right? Which means the forward reaction is going to increase. Right. When that happens, as the forward reaction increases, the reverse reaction, right, to re-establish equilibrium, actually, let's put it that way, to re-establish equilibrium, this has to decrease to consume the some of the sulfur dioxide and decrease the partial pressure of sulfur dioxide. And in the process, the reverse reaction will also start to increase to catch up. So I've got my reverse reaction and forward reaction there. That means this answer is not correct. Why? Because when the reverse reaction increases to try and, as this is being consumed and the collisions will build up as the sulfur increases, it means the rate at which sulfur is being produced is going to increase, which means B is not correct. So I've got a 1 in 3 chance now. Add a metal catalyst to the vessel. No, it doesn't affect anything, because if you add a catalyst to a system that's at equilibrium, it looks something like that, because this reaction is endothermic. The catalyst offers an alternative pathway of lower activation energy, which means, but when it does that, it lowers both the forward and reverse reaction proportionally, not equally. It's not equal, it's proportionally. Right, so what do we mean by proportionally? Let's say I've got two numbers, 4 and 2. Right, if we add a catalyst, it reduces this by the same amount. But then let's say that factor is a factor of 2. And if I divide this, I end up with 2 to 1. This here is just the same as that, because the ratios are just the same. These are just like equivalent ratios or equivalent fractions in a way. So a catalyst will not affect a system at equilibrium. Adding a catalyst, heating the reaction vessel. Energy is a reactant in this reaction. It's a reactant. So what's going to happen is the system will try to consume this energy, favoring the forward process. So initially, like with the previous case, both the forward and reverse reaction are going to be favored by increasing energy. But because energy is a reactant, the reactants are going to be favored more. So in a way, if I was to draw the reverse reaction being favored in blue, I'll draw it with a blue line there. You can see that. Now, what will happen is this one will decrease, trying to re-establish equilibrium, which means the forward process will decrease, trying to re-establish equilibrium, while the reverse reaction increases. And here is a reverse reaction. We can see that as well, just like the same reason we gave here. This will actually see an increase in the rate at which sulfur is being produced, which gives us A as the most correct answer for this question. Right, I'm going to love you and leave you. I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I'd love to hear any questions, any concerns, or anything that you think could have been done differently in this video.